Imagine an animal that can handle being heated to 148 degrees Celsius, being frozen to minus 272 degrees Celsius, which is almost absolute zero, and withstand radiation levels that would be lethal to you and me. Well, imagine no longer. You might not have heard of them, but I'd like you to meet what I reckon are the toughest animals on Earth: tardigrades. If you've seen pictures of them taken through a microscope, you'll know that they are also the cutest. Well, at least I think so. They are the stuff of science fiction with powers beyond belief. Don't you just love that feeling of drinking an ice-cold, thirst-quenching drink on a hot summer's afternoon? Now imagine you've had to go a whole day into the evening before having a drink. Most of us would be feeling a bit faint by that point. How about 2 days? Now we're getting into the territory of serious dehydration, right? And what about 3 days? Well, on average, that's as long as most of us could go without a drink of water before dying of thirst. Only 3 days. Well, there are some super tough organisms out there with the astonishing ability to survive near complete dehydration for more than a year. And they do it through something called anhydrobiosis, otherwise known as a life without water. One of the animals that's best known for this is the tardigrade. And that's why biologists are so interested in them. Affectionately known as moss piglets or water bears, which I quite like the sound of, tardigrades are unlike anything you've ever encountered. At about 0.5 millimeter in size, a light microscope comes in handy if you want to see them clearly. But I can hear you already bellowing at me from home. Who has a light microscope just lying around, Patrick? Well, if you don't, no worries. I have the perfect recipe to help you spot your very first water bear. We'll start by taking 1 clump of moss, about 2 centimeters worth. Next, add some tap water, ensuring all your moss is well wetted. Now set your timer for 20 minutes. Kick back, relax, and allow your mix to soak. Once your timer goes off, squeeze out all the water into a flat glass dish and let the mud settle. Finally, scan the dish using either a hand lens or a magnifying glass if you have one, or you can get yourself one of those snazzy clip-on macro lenses for your smartphone. If you look carefully, you should see a whole bunch of tiny creatures moving around in the water. Keep your eyes peeled for something that looks like, and you are hearing me correctly, so do not adjust your smartphone or your podcast app, something that looks like a miniature vacuum bag with 8 legs stuck to it. I mean, bizarre doesn't even begin to describe these things. Most have a pair of small black eyes, and a few even have body plates. When it comes to feeding time, some are omnivorous. In other words, they eat plants and animals, as well as algae and fungi. Others, however, are ruthless carnivores and prefer to hoover up other small species of tardigrade. Tiny sensory hairs line their mouth, which helps to guide food into a specialized pharynx or tube, which sucks food into the gut. So, you get the picture. These things are incredibly small in size and strangely cute in appearance. But the reason I'm talking to you about them today is because despite their extremely small size, they are virtually indestructible. And when I say indestructible, I mean they have even survived a trip exposed to the vacuum of space and back. I told you they are indestructible, but they also like to get around. From living in the moss in your garden, they've been spotted way up Himalayan mountains over 5,500 meters above sea level, in the hot springs of Japan, and even at the bottom of the Antarctic Ocean. They are the ultimate intrepid explorer, and because they can survive such extreme conditions, they've earned themselves the title of extremophile. It was a Dutch scientist, Antony van Leeuwenhoek, who in 1702 first described tardigrades in a letter he sent to the Royal Society in London, England. He'd taken some dry, seemingly lifeless dust from a roof gutter, added some water, and using a rudimentary microscope, he found what he described as small animalcules swimming and crawling around. I absolutely love that description, animalcules, and it has a certain Darwinian ring to it. But it's the German pastor Johann August Ephraim Gotzer, who is generally acknowledged with their discovery in 1773, that first referred to them as little water bears because of their appearance and bear-like walk. but their common name can be attributed to Italian scientist Lazzaro Spallanzani. He named them Il Tardigrado, meaning slow stepper, because they move so slowly. What he didn't know was that under certain conditions, they slow down so much they go into a type of suspended animation. You see, one of the most astonishing things about tardigrades is that whilst they live in water found in soil, mosses and leaves, they can in fact survive for long periods of time without it, months, even decades. When a tardigrade dries out, it responds by retracting its head and its legs, and then more or less shuts down its metabolism to less than 0.01% of its usual state. A dried out tardigrade is called a ton, but don't ask me why. All in all, these actions preserve the tardigrade until it's rehydrated and springs back to life. The question is, how long can they stay suspended like this? Well, in 1948, Italian zoologist Tina Franceschi claimed that tardigrades could be reanimated from samples that were over 120 years old. That particular experiment is yet to be replicated, but a team led by Mark Blackster at the University of Edinburgh in Scotland have for the past 4 years successfully observed live tardigrades from specimens of dried algae, which they rehydrate and check every year. For most animals, life without water is impossible. And that's why these tardigrade resurrections have not only challenged our understanding of the boundary between life and death, but also inspired a new wave of potentially life-saving applications. If you're enjoying this video, make sure you hit that like button. Liking the video does wonders for the channel and helps to spread this video to more people just like you. And if you're a fan of nature-inspired solutions and success stories like this one, 30 Animals That Made Us Smarter, the book, might just be for you. Check out the link in the description to order your copy now. All right, let's get back to the episode. So let's begin with how anhydrobiosis actually works. It was Californian researcher John Crow, now Professor Crow, who in the 1970s realized that the key ingredient was a type of sugar called trehalose. And it's this trehalose that the tardigrade uses to replace water molecules in its cells when it dries up. By doing this, it maintains its structure on a molecular level until water becomes available again and the cells are rehydrated once more. Crow realized that the implications were really exciting. If trehalose could stabilize the cells of the tardigrade, could it also protect human cells, like blood for example, from becoming damaged when they dried out? Now, of course, you wouldn't want to dry the blood inside your body. That definitely wouldn't end well. But what about blood outside the body? According to the World Health Organization, more than 100 million blood donations are collected every year. The donated blood can be separated into its different components, whether it's plasma or platelets. This is then used in life-saving transfusions, replacing blood lost during surgery, after serious injury, or in some cases where patients are unable to make blood properly because of an illness. Platelets are particularly useful when it comes to wound healing, but they can be challenging to use and store, and here's why. You might think that you could just keep platelets refrigerated, but this would destroy them. So they have to be kept at room temperature, which also means they have to be used within 3 to 5 days before they go off, so to speak, and have to be disposed of. But what if you could add trehalose to the platelets? Well, then we could freeze dry them and keep them as a powder for up to 2 years. This means they can be transported and even flown to places which would otherwise be impossible. This new tardigrade tech is currently going through clinical trials, and if they pass, blood platelets will become far more readily available for saving lives around the world. And that's not all. There are other potential applications. Vaccines, those life-saving medical preparations which protect us against diseases like hepatitis B, cholera, polio, and Ebola. The vaccines for these diseases are hard to transport. In fact, around half of all vaccines become inactive during transport because, unlike platelets, they do need refrigeration. And it's not always easy if the electricity is unreliable or just not available. Even if they do reach their destination intact, they have a limited shelf life and must continue to be kept cold. But if we could dry them out, vaccines could be transported and stored at room temperature, then activated by adding water when needed. In this stable, easy-to-transport form, scientists suggest that vaccines could be shipped to the most remote corners of the globe. The hope would be to extend the shelf life of these substances from mere days to months or even years, transforming medicine everywhere, from rural Africa to the battlefield. And as well as helping out here on Earth, this tardigrade technology could be useful in space. Thomas Boothby at the University of Carolina has been leading a project with NASA to grow tardigrades on the International Space Station. Prolonged spaceflight can have detrimental effects on the human body. Boothby is interested in how tardigrades cope with the effects of low gravity and increased radiation exposure. His hope is that tardigrades can combat the stresses of spaceflight. If they can, then we might be able to use this knowledge and apply similar tricks to protect astronauts during long space missions. So, an animal you may never have heard of with a tenacity for survival is inspiring some really innovative and life-saving medical applications. Not bad for a creature that's less than 0.5 millimeter in length.
If you enjoyed this video, make sure you hit that subscribe button and head to the comment section to share the ingenious ideas that you've come across too. For our offers and much more, head to the episode description below. And if you're looking for more great content, then check out this next video. Thanks for watching.